be recording this. And I will make it available as the proceedings post webinar. And you can always share this recording with others in your municipality who you feel are interested or should be interested. So in that note, I will turn it over to Lucas. And just before I do, if I can ask just a reminder that for folks who are just joining, and please just throw in your name, say hello in the chat function. Just want to save time and use people's time as efficiently as possible. So we'll use the chat function for everybody to introduce themselves. So thank you very much. And I'll turn it over to you, Lucas.
Thanks so much, Gabby, and welcome everyone. Thank you so much for that little history lesson there, Gabby. I think it's super important to for us to have those conversations about our country's history and some of the challenges and struggles that Indigenous people have and continue to go through. So much appreciated. To everyone else who's on the line today, thanks for joining us over this afternoon. I hope that many of you are familiar with CBAT to some extent, whether you've been on a webinar in the past or seen it I don't know, through one email or another. Hopefully we have a general understanding of what the tool does, but for those who might need a little bit of a refresher, I'm going to reacquaint you with a little bit of the what the tool is intended to do, some of the challenges it hopes to address, and ultimately how you can go about using this tool to drive some of your decisions. We're going to keep it pretty conversational. I don't want this to be me just talking up here for an hour and a half. I don't think anyone wants that. So like, if you have any questions, feel free to throw them in the chat or just unmute yourself and stop me mid-sentence. I think, if you have a question, there's likely others who are going to have the same question, and it's probably to everyone's benefit to get that answer and knowledge out in the open. So yeah, again, just feel free to jump in at any time. Okay, so with that, and I'll also mention we probably aren't going to take the full 2 hours here. Like, I'm thinking maybe between an hour and a half. So just in case anyone's trying to make plans for later. Okay, so we're going to talk a little bit about what type of questions CBAT aims to answer, how we've been able to connect costing and energy modeling to create this tool that hopefully supplements what all the tools that industry currently has available to them. We're going to get under the hood of CBAT, so examine some of the tech or some of the ins and outs of how we generated all the data to use for some of the analysis. And we won't talk too much about CBAT in industry. After this short overview here, we'll just jump right into the CBAT tool. It's an Excel spreadsheet. Following the webinar, I think Gabby is going to share with you an updated link for CBAT, for like a new version of CBAT. We've been working pretty diligently on incorporating some of the feedback and recommendations that we've received over the past year or so, and we're in the midst of about to release like the next version of it. Prototype available that most of you can download following this call, and that's the one we're going to be working off of today. So one of the big questions here, as we see tiered codes coming in, and we're being asked to target higher performance buildings, is how do we do it in an affordable way? How do we reduce energy, and how do we reduce GHGs in a sustainable and cost-effective way when looking at it through today's lens? In terms of how much is it going to cost to build, how much is it going to cost the homeowner in terms of a down payment, and then also like taking that lens to look out over 10, 15, 25 years, 100 years even. I mean, for the life of the building, what's it going to cost for it to offer, a service to citizens, to house and to provide shelter for generations and generations to come. And so we need to look at, I guess, what is going to be the cost and what's going to be the benefit of some of these decisions, and how can we make confident and appropriate decisions that are going to be long lasting and self-sustaining. So a need was identified by industry to develop resources and tools to help guide them through this transition from what our typical housing looks like today to what we hope to be net zero ready in the coming years. And some of those questions arise around what technologies and practices should we adopt? How do we achieve the desired level of home energy performance for the lowest possible cost? We know there's many different combinations and design options to construct a home, but how do we know which one's going to be the most cost effective and the lowest cost? And that comes to that conversation of optimizing your build costs. So that way you're not leaving anything out on the table. Excuse me, I'm just going to clear my throat here. I did a presentation earlier this morning out in Edmonton with some builders. And so my voice is going a little bit today. So just bear with me, please. And then lastly, it's like, after we've optimized these homes, it's how do we deliver affordable and energy efficient houses? And I think that's, energy efficient, we can extend that to, low carbon if we're really taking, a good kick at what our real objective is here. And so these are pretty big questions, and it's kind of tough for any single person to answer them for all the different builds and all the different design options that exist for your market and for the type of home you want to build. So what kind of questions can CBAT help you answer? Well, it looks at what technologies that can be incorporated into the home and what their energy impact is, what the cost of these energy efficient measures are using your prices. We have some pre-built default data in the tool right now, which I'll take you through when we get into it. But I wouldn't say like it's not 100% accurate. Everyone's going to look at it, and there's going to be probably a number of costs that are a little bit out of whack. But the purpose of the tool is to customize them and tweak them so that way they make sense for what you're seeing, and you can get some meaningful results out of it. How can I be sure my energy efficient house is cost effective? Well, yeah, that's a pretty important question for the builder as well as the homeowner. And then lastly, what energy efficiency or low carbon programs can I target with a fixed budget? If I have X amount of dollars to spend on energy efficiency, how can I ensure that I'm getting the most energy and carbon reduction out of every dollar I spend?
Right.
We know energy efficiency codes and programs are well on their way, and they're making their way to almost every municipality in Canada. With the tiered codes about to get rolled out, as well as voluntary programs. We just saw one that came out for retrofits, the Greener Homes program, and so there's going to be more programs and more codes and more programs and more codes. There's going to be more, I would say, more of a transition, and one that we need to make like really quickly to get to where we need to be by to hit our net zero and net zero ready targets. And that's going to require a lot of changes to what we currently do with our building practices, as well as how we're typically used to building homes. And these voluntary programs, they help act as stepping stones to get us to where we need to be, in the hopes that we can make like incremental change to our current ways of building, and that we're not just kind of hit over the head with going from 0 to 100 pretty quickly. So the tool.
Sorry, Lucas, just one question I wanted to ask. Just I must want to make sure I'm not incorrect in saying this, but the National Model Building Code only looks at the operational stuff, at operational energy. It doesn't look at embodied energy or embodied emissions. Is that correct?
That is correct.
Okay.
Yeah, it's only looking at energy.
And the CBAT tool at present doesn't bring embodied carbon. It looks at it more from an operational kind of cost benefit analysis. Is that correct as well?
Yeah, that's correct. So CBAT looks at it from an energy perspective as well as an operational carbon perspective.
Okay, perfect.
Yeah.
I just wanted to kind of mention that just because Alan was curious about that. I know that if I can interject, I did want to kind of mention that we will be there is some significant work taking place to bring in embodied carbon into decision making, but it's still at the earlier stages. But we will be coming back to the municipal network with work taking place with Chris Magwood and his team at the Builders for Climate, Builders for Climate Action, I think, network. I can't remember. I'm trying to remember. All right. Something like that. But Chris Magwood, and we're working with him, he's just doing some benchmarking on embodied carbon, but it is coming into the mix. It's just at the earlier stages. Sorry for interrupting, Lucas.
No, no worries. Super important question. I think it's a really important topic as well. The topic around carbon and how our codes aim to really address our goal of reducing carbon. And so it's going to be really interesting when we start factoring in embodied carbon, operational carbon, and really considering what our different mixes, like what the fuel mix and the GHG emission intensities are for all of our grids. Yeah, going to be super eye-opening, and it's going to be, this tool hopefully will provide some really good insight into how we need to make our decisions to align with the code, and how they're going to ultimately push us in the right direction, or and how we can better that. So just jumping back on track here again. Thanks, Gabby. Just interrupt me as I go here. Let's just keep it free flowing. I'll go through this pretty quickly. I'm sure most of you are eager to see how the tool works and to familiarize yourself with some of the inputs. So similar to what we're doing here today, we did before COVID, we were doing in-person workshops where we had everyone kind of in the room, bringing their laptops, and we actually loaded the CBAT tool. We put it on a USB and handed out a number of USBs to all the participants, and they loaded it on their tool, and they spent 2.5 to 3 hours getting instructed on how to use the tool and how to customize it to kind of fit some of their needs. Really, really great engagement. We ran a series of these across Canada, from the East Coast all the way to the West Coast here in BC. And yeah, we got lots of feedback, lots of suggestions, good ideas as to how builders and different stakeholders saw the tool being used for them, for some of their work. And we've taken a lot of the feedback and suggestions that we've heard over all of these different engagement events, and slowly but surely starting to solidify and bring all of these and consolidate all of these findings and suggestions. That way we can make a pretty robust tool that aims to answer all of the questions we might have about code and what optimal solutions or recipes might look like. So combining costing and energy modeling, I hope most of you on the line are probably familiar with HOT 2000. It's the energy modeling tool that we all use here in Canada for residential buildings. It's used for compliance purposes and for understanding how much energy a building is going to use on an annual basis, from heating, cooling, plug loads, and just kind of understanding what its thermal performance is. So some of the limitations with HOT 2000, which I think everyone is also aware of, are that you can only look at upgrade scenarios one at a time. So if you're trying to ask yourself, well, what happens if I go from an R22 to an R24 wall? What's it going to do? And so you have to run another simulation to answer that question. Or if you want to tweak the efficiency on your mechanical system, or add a new solar heat gain coefficient for a window, it just requires runs and runs and runs, and you're limited into how much time you have and how much patience you have as well. And so what we've looked to do is create essentially a machine that kind of takes that part of it out of the mix for you, and kind of dumps 50 to 100,000 of those scenarios in front of you for you to then evaluate and make decisions based on building science, all the important stuff that energy advisors add into this part of the process. And so the other part of HOT 2000 is that it costing or optimization. And when we're working with builders, with homeowners, with anyone, I mean, cost is always top of mind. And so a way to combine the energy modeling and the costing together. And I think that's what we've aimed to do here with the CBAT and the HTAP tool as well, where we've come up with a number of HOT 2000 runs, in the order of tens and hundreds of thousands. We've layered on costing for each one of those runs, and enable you to actually modify those costs, as well as filter through any of those runs, so that way you're getting recommended a solution that makes the most sense for you and for your market, for the prices that you're seeing, for your suppliers, your trades. We want to make sure that however you get to step 1 or step 2 or step 3 in the code, that it's you're confident in it and to do it cost effectively. So we designed the tool in a pretty hopefully a pretty streamlined way. You can download CBAT for your climate zone. So that's off the Google Drive, and I'll kind of take everyone through that in a moment. We also have, we're also working on the ability to run CBAT for your customized home. So if you're developing a hot tooth, right now CBAT has a number of archetypes built in it, and we've done those 50 to 100,000 runs on those archetype homes in predetermined locations across the country. And so that's what everyone has access to right now. And so the idea is you pick an archetype home that's most representative of the one you're trying to build or the one you're trying to analyze, and that's where you would get your insights from. But what we're working toward right now is allowing users, what I would typically think would be those who are pretty comfortable with Hot 2000 already, to be able to take a Hot 2000 file and run it through HTAP, generate your 50,000 or 100,000 runs, and pull that information into CBAT, where you can then do your cost. Talk a little bit more. I'll talk about that in a little bit more detail later, and we'll talk a bit about a working group that I'm trying to put together with some folks who are pretty keen in understanding that process. I mean, it's not super simple, but it's not rocket science either. So I think we've got a few individuals who are pretty interested already from a few trainings I've done in BC and on the West Coast. So about learning how to use HTAP and CBAT for customized or your own project files, then feel free to reach out to me afterward. I'll connect you with our working group that is hopefully about to launch. So got a little bit sidetracked there, but archetype. So the version that's available to everyone is the archetype. If you go through the custom route, then you would import your analysis on. You choose what your reference house would be or your costing base case. And then we jump into specifying the energy efficiency target, or if you have a fixed budget, you can customize the costs and the upgrades that make sense for your project. And then you can find optimal solutions or optimal recipes and packages that help you hit whatever tier in the code you're going for. So this is kind of what 50,000 Hot 2000 runs look like. Each one of those dots represents a unique design for a particular home. And each one of those dots, as you can see, has a cost as well with it. On the y-axis is the change in purchase price. So going from base case to whatever other level incremental cost, as well as the energy savings on top above that base case that we've specified. And so if you're trying to go for, as we're starting to introduce different levels of performance and tiered codes, we can see that there's a lot of different options, a lot of different dots that fall within each one of those bands. And I think everyone on here hopes that whatever decision that they come to puts them kind of along the bottom of this cloud or along that red line. And what that's telling us is that you're hitting your energy savings for the lowest possible cost or the lowest incremental cost. And I don't think any one person could possibly evaluate this many Hot 2000 runs manually. And so I think this is where some of the power of this tool comes into effect, where it just generates this cloud of data for you. And then you can start layering on your calculations and putting in your inputs and costs and applying building science knowledge and and experience based on past projects to some of the solutions that it offers. CBAT basically takes this big cloud of data and translates it into specifications for you. So it recommends air tightness levels, envelope insulation levels, mechanical systems. And so everything that you see here on the screen is what it's able to include in its cost benefit analysis or its trade-offs. We're looking at, in this particular, it shows us a number of different performance levels for each of the categories. And this one here is to hit step 3 in BC. And at the bottom there, we can see that it provides a number of costs. The important part of this tool, I think, also is that we can modify any of those costs. So none of them are written in stone. If there's a number that we want to change later on in terms of what an ECM cost might be, what a maybe the price of lumber, you want to keep that regularly updated as it's changing so much, then you can make sure to do that, and your recommended solution will reflect the numbers that you can put into the tool. Under the hood of CBAT, again, we mentioned lots of runs done on archetype homes. We did it for 16 cities across the country. It's a preloaded costing database that's in the tool. It's a national average. It's not regionally specific. So it's great to understand relative differences between levels of performance. But it's like any modeling software, it's garbage in equals garbage out, and costing is part of this equation. So you got to make sure it's the results are going to be as accurate as your costs are. The tool provides financial calculations and energy reporting. So we look at construction costs, net cost to buyer, net present value, total cost of ownership. In this version of the tool, I've been kind of experimenting with a couple of other reporting criteria. So it'd be great to get everyone's on the line's feedback as to what they think of it as well. And if there's some on this list that you've been finding success with, or others that you want to have added to it.
Lucas, just a question. I just wanted to kind of throw it in there just to kind of get a little sense of how the tool could possibly help with these kind of decisions that get taken, that get made. But Matthew is just wondering, how does the tool determine when an addition of an HRV is required due to the increased air tightness, and how it is factored into the cost? Like, how would the tool kind of help you make those decisions?
Yeah, so that's a good question. This is, I think, why it's super important to keep an energy, to have your energy, to work with your energy advisor, because they'll be able to apply the building science knowledge and principles that make sense for different builds. And so we have a number of disclaimers built into CBAT. So if you get below a certain air tightness, then you need to go with an HRV. But they're there for somewhat educational purposes. But again, you don't want to rely on the tool for that type of building science insight quite yet. To certainly keep an energy advisor close by, and they can most definitely help you understand, how to make the correct considerations and how to avoid any unintended consequences. Okay, so that's kind of the end of my little presentation here. We'll send this out to everyone at the end of at some point today. There's going to be a download link again where you can go for the CBAT tool, and you can play around with the prototype that we're going to see here today. And then just feel free to contact myself or Gabby if you have any questions on the tool, and or if you're again interested in being part of that working group. Looking to maybe meet once a week, that kind of commitment. Yeah, the goal is to just be able to take a Hot 2000 file, run it through HTAP, and import it into CBAT, and be able to do that customized analysis for your project. So that's kind of our overall arching objective for everyone who wants to participate. Okay, so I'm going to pause my screen, or pause my presentation here.
Here's another question just before
Sure.
we get into it. So, can the tool handle various approaches to optimization? For example, if someone says I have $5,000, how can I get the best bang for my buck? Or I want to add new windows and insulated siding, even if they are not the most financially effective or reducing my energy consumption. What is the best combination of siding and window specifications I could use to get the best bang for my buck?
Yep, no, great question. I mean, I think that's kind of the crux. This is what the tool aims to answer at its core is, how do you get the best value per dollar spent? And so within the tool, you can actually, I mentioned in the presentation there, and we'll demonstrate it here today, is where you can specify a fixed budget. And then the tool, if you say you have $10,000 to spend on energy efficiency upgrades or ECMs, the tool will do the math and figure out how you can extract the most energy or carbon savings, or find the lowest total cost of ownership given those parameters. In terms of kind of forcing it one way or another to put in certain windows, that you can also have the ability in the tool to go through all of the measures we've listed and kind of tick no next to them. And so what you're telling CBAT is, don't include these measures or these ECMs in my optimization. And so, a great example is if you're in an area where there's no natural gas available, then you tick no next to all the natural gas options that we have, and CBAT would recommend a way to hit whatever energy performance level with only electric solutions.
Gotcha.
So you can force the tool, you can force and manipulate the tool to kind of, if you don't like the, I was talking to my colleague earlier, Patrick, and I think he said it quite well. He said, if you don't like the answer that CBAT gives you, you can ask the question in a different way. And so I think that's what's really powerful about it, where you can really customize that solution and it'll tell you within whatever constraints that you present it, or most cost-effective solution will be.
Perfect. Thank you.
Okay. So again, I mentioned that we'll send out a few materials after the presentation here. I just wanted to show my screen for a second. We've developed a number of YouTube videos as well. So we'll send out this link where, it shows you how to download the tool, shows you how to import your archetype as well as play with costs. So there's a set of about 7 videos, as well as an accompanying PowerPoint presentation that we'll share with you. And I think it's pretty helpful. It'll help you definitely get through some of the early hurdles of using the tool, and certainly a useful resource if you're teach or explain the tool to others as well. Okay, so now I'm going to flip to my Excel sheet. As I'm going through this, just raise your hand, put a question in the chat. I think, Gabby, if you could please just monitor the chat. You've been doing a great job already.
Lucas, I'll field it. I'll take care of it. Yeah.
Awesome.
Yeah. I don't know about you, but I can't multitask. I can't read and present at the same time. So I'll just take care of all the questions. You don't need to worry about it.
Wonderful. Thank you. Okay. So on the first page of the tool here, this is the Archetypes tab. This is where you can select from the 4 archetypes that we've already preloaded into the tool. And so you can pick from the drop down here. Let me zoom in for everyone.
Oh, sorry, Lucas, another question that just came up that I missed earlier.
Sure.
It was the question with regarding the costing of CBAT is in dollars above a benchmark rather than a percentage. How would the CBAT tool take, rapidly increasing costs of materials into consideration? Like, how would it be able to do that? And or if not, is there some sort of calculation, with the difference in lumber prices now and they were 2 years ago and all that kind of stuff? How would you, what could be a possible workaround for that as well?
It's a good question. I don't think anyone's asked that one yet. I mean, we've considered the escalation rates. I would coin it like the escalation rates. That's what the term I would use. And so like how much it increases or decreases over a period of time. So we've accounted for the escalation rates of electricity costs, carbon costs, as well as carbon taxes. We haven't done that yet for materials. So it's not in there.
Right.
If you want, you could just do 2 separate runs. I mean, do one run at today's material cost, do another run at tomorrow or a year's, whatever you predict it to be a year from now, and do that run at that time. But no, don't have those escalation rates yet for materials.
Yeah. All right. Perfect. Thanks.
Okay. So back to the archetypes tab here. So you can select which of your archetypes you want to use. Whether it's small story, large 2-story, the row house, or the modular home. You can also select what your base case is. So this is important, obviously, for trying to understand how to meet our house, and have to understand what the percent better is for heat loss, envelope improvement, as well as just overall home improvement, home energy performance. This information is just gets spit out to you based on what you've selected and the version of the tool you've downloaded. These are the architectural takeoffs. So this is where you can confirm what the areas are of different architectural features of the home. And this is what we use for our costing calculations. So if we're trying to cost out exterior insulation, And we have a cost per square foot for XPS. Above grade, we would multiply our cost per meter squared or square foot by whatever our value is here. And so this information comes straight from the HOT 2000 file. So whatever you've done to model your geometry will get carried through to here. The buttons here are to load your base case. So that pulls in whether gas or electricity. You click to load your archetype. We'll stay on the modular house for today. And then you click this button to import your run data. And so that just takes those 50,000 runs and pulls it from one of the CSV files that accompanies the CBAT tool and ports it into the spreadsheet itself, so you can start doing your calculations on it. Okay, that's it for the archetype tab. Any questions?
There's a couple of questions. So
Sure.
I'll go into it too. It's like, does the tool take into consideration possible increased maintenance costs associated with different types of energy efficiency technology? For example, if you're switching to an air source heat pump, but from old reliable baseboard heating system, is there like just maintenance and operational savings, not so much the actual the material, like the installation, but longer term maintenance?
Yep. Okay. Great question. We definitely have that covered in here. At the bottom of the screen, you can see something called life cycle costs. And so here's where I'm thinking whether I want to go down this rabbit hole right now or not. We do account for it. We don't account for like the escalation of it. So we can't necessarily say like, it's going to cost you $100 a year today to maintain your furnace, and 10 years from now, it'll cost you, $120. We don't have that kind of math built into it, but we do account for the total cost of ownership. And so that looks at your maintenance as well as your replacement costs. So if you're doing a total cost of ownership calculation over 50 years and your heat pump only lasts 20 years, well, you're probably going to need 3 heat pumps in the course of that life. And so what's the cost of replacing it, as well as whatever annual maintenance comes along with it.
Okay, but that data is like that raw data assumptions is part of something you can pull into your analysis.
Sure. Yeah. Okay. I'll just show everyone so we're not speaking so abstractly. So here we have our maintenance and replacement. So on the left is all of the different ECMs that we have available. So whether it's your insulation for your ceiling, above grade walls, windows, slab, air tightness, mechanicals. And for each one of them, we have a service life. So all of these inputs, like these are just assumptions we've put into it. By no means are they correct. So they're all fully customizable. So you can play with any of the numbers in column C to E and adjust them. So that way they're reasonable and you're comfortable with them. So like on the ventilation, for instance, we see here, we have our HRV lifespan is 20 years. What we're saying is we got to do maintenance every year. Maybe it's a filter or something, and that's going to cost $20. And so we could change this to be every 5 years, because we know some people don't do, the maintenance every year as diligently. And so we can adjust that to make it more reflective of what's actually going to happen. And then we can understand as the total cost of ownership on the far right-hand side here. And so that's just first cost plus, if you have to replace it, plus your maintenance cost times how often you have to do that. And you can play with this by changing your total cost, like the number of years you're looking at. So whether that's going to be, 5 years, 20 years, 10 years, it's going to update these numbers here. So that way you can see what is the total cost of actually owning that house over the duration you specified.
Perfect. And then another question that came in from Kelly is, how do you connect to the HOT 2000 file for the areas, or is this just only with custom archetypes?
That's only with custom archetypes. So when you generate the data required for a custom archetype, part of that data set includes the geometry of the house. And so that's kind of the connection. So you take a HOT 2000 file, put it into HTAP, it generates this data, and then it puts it out in Excel format for us to use in CBAT. So the connection to HOT 2000 is HTAP.
Okay. So like that, The Hot 2000, if I remember correctly, just kind of correct me if I'm wrong, the Hot 2000 is like your big database, each individual project with all the measures all put into it. Is that correct?
Yeah, Hot 2000 is kind of like the engine, or like,
Okay.
Hot 2000 does all of the the energy simulations for us. HTAP is what allows us to do lots of simulations, lots of different permutations. And CBAT just helps us understand and visualize the data.
Gotcha.
Okay.
And out of curiosity, another question that's coming up in terms of it. This is all the CBAT tool is definitely geared towards the energy. But if you wanted to kind of, let's say for green development standards that municipalities have, you wanted to kind of use like a TEDI or thermal energy intensity kind of calculation or a GHG emission kind of calculation, how would CBAT be able to help you, or how would it where it might not be able to help you?
Yep. Okay, I'll start with the envelope part of it. So the TEDI in the new building code, or if you're in BC or any other jurisdictions that require a either a TEDI calculation or a percent improvement on that heating intensity on the envelope demand, then that it gets included in our inputs tab here. So we can see for NBC 936, this is what our reference house consumption is, and this is for tier 1, this is what our target is. So tier 1 we're saying is essentially the new and updated reference house. Tier 2, we can see it's a slightly lower consumption that we're targeting, so that's a 10% improvement, and we're also targeting a 5% heat loss reduction. So these are the new metrics that are being proposed for the new tiered code, the federal tiered code coming out. Gabby, could you remind me, please?
Yeah, and then there was just how you would translate that into GHG emissions, since the tiered code only looks at energy.
Yes. Very, very great question. And I think this is hopefully where CBAT can help provide a lot of insight, is just seeing how our code aims to address carbon emissions and how effectively it's doing it. And so what we can do as we scroll down in our inputs tab here, so this is where we select our efficiency. This is where we can input what our PV is, but we can also start to specify utility costs, carbon taxes, as well as our GHG emission intensities. So if we're just looking at operational carbon, so how much carbon is emitted from your electricity as well as natural gas consumption, we can put an emissions intensity or emissions factor on each of those fuels. And so we can understand what the operational carbon is. We're not, like Gabby said, we're not necessarily at embodied carbon yet, but that's coming really soon. So once we're able to specify what, how much CO2 we're consuming as a result of a kilogram of, or a meter cubed of gas or kilowatt hour of electricity, we can then optimize for, well, we can first see how much carbon we're using. Let me put something here. So we can scroll down here and see how much carbon we're actually using. So this particular example, this is one we looked at today, and I thought it was pretty eye-opening. Is we're in Edmonton, Alberta here, and we're trying to hit step tier of the proposed code, and we're seeing that there's no carbon savings here. And so, while we're still meeting an energy reduction requirement, the fact that we've been able to hit that by switching to electricity and, considering what the grid mix might be and the emissions intensity might be in Alberta, we can see that this particular home is meeting step 2 and really not doing a good job of reducing carbon. So these are some of the insights. And I mean, you can, and this is where it's really, this is where I would encourage everyone to really dive into this and put in your own, make sure the emissions intensities are correct. This is where you'd want to be looking at your specific building and your specific climate zone, and just doing that ground truth to make sure what's coming out is making sense to you. But it's pretty interesting to see how, because we're looking at 50 to build this house, there's bound to be ways to hit these levels of performance and not be able to reduce carbon just based on the grid mix there. So yeah, really, really interesting results I think that can come out of this, and hopefully it'll generate some really good discussions and push us in the right direction sooner than later.
But this is really helpful for understanding what the difference between looking at an energy metric and a GHG metric might make, because I have heard of the BC step code and the challenges with regards to the energy metric, like their tier 3 of the energy step code has more carbon emissions, even though it's more efficient than a step 1 that's electrically heated is, right? So it gives you that kind of ability to understand, if you look at it from an energy metric, here's where you get, but if you look at it from a GHG metric, here's some of the things, and then understanding the tweaks that you would need to make it work for both energy efficiency as well as greenhouse gas emissions.
Yeah, absolutely. And yeah, I think you make some really good points there, Gabby. It's going to be really important to consider this, as with every design decision, because I mean, if we're reducing energy, but not reducing carbon, we're not doing it. We're not accomplishing what we're out here to do, right? We're spending more money and going backwards. So that's a big no-no, I think.
Yeah.
And folks are going to have a lot to say about that if that's the case. But yeah, so we'll keep going through the tool here. Great questions by everyone. I think it's, if you have more to add to the discussion, feel free. I think there's a lot of, it's a really interesting time. One more thing,
just before you head on, I just wanted to get some clarification on this one. Urshad was just asking, like, in terms of where the raw data comes from on the costs and how it was submitted to NRCan, that comes from the builders directly. Is that correct?
I wouldn't say it comes from the builders directly. Like, the numbers that are in the tool right now, again, are probably collected. They're an average over maybe the last 5 or 10 years. They're from a collection of pilot projects, case studies, industry engagement events that LEAP has had. And
but it would also be based on, like, so it's actually based on real world examples, though.
Yeah, the data, at one point, yes, it was real world, and it was, 100% accurate for, a small, probably tiny point in time.
Yeah.
So yeah, that's kind of the caveat there.
And it does cover like a wide geography of Canada, the raw data?
It does, yeah. So it's not regionally specific, and I think that's something we're aiming to improve, is to get regional specific data. So we're working on it on the retrofit side of things, but we still haven't gotten a good sense of regional costing data on the new housing side of things. So, not everyone's always super willing to offer their costs up.
Yeah.
So I guess that's kind of the impetus for this tool, right? Is that, you can put your own costs in, you don't necessarily have to share them, and you can still come out with this type of knowledge and insights.
Perfect. Thank you. And then another question, just in terms of, let's say you were going to put PV panels on, like on a home or anything like that. Would CBAT be able to help you with that kind of analysis of what that means?
Yep. So right here, you can see we talked about how much PV is generated and how much PV is required if you're actually trying to target that net zero ready or full net zero build. So yeah, it accounts for PV, and it'll also reflect in your utility costs as well, because you'll be using less energy from the grid.
Gotcha. And it wouldn't give you any guidance, like, if you have this amount of roof area, you should probably install this much. It's asked, you have to give it the data on how much kilowatt hours you're going to be producing, right?
Yep. Exactly as you said, Gabby. It doesn't do any of the solar calculations for you. It's recommended that you work with a solar PV consultant, and they'll be able to tell you how much PV you can expect to generate on your roof.
All right, perfect. And then, sorry, just a couple of more questions.
Yep, go for it.
In terms of the tool, it won't provide you any projected changes in cost of energy over the years. Is that correct?
Nope, that one's incorrect. It does incorporate that. So, okay, thanks. That's a good question. It keeps us back on track to the inputs tab here. So as we continue to go down here, we can see our utility costs. So this is what you're inputting for today. So whether it's $25 as your fixed cost, and then 6 cents per meter cubed is what we're seeing, as well as if you have a natural gas or a carbon tax for either one of the fuels. There's builder finance inputs, so profit margins, overheads, home buyer finances. So when we're trying to calculate that financing cost, mortgage, amortization, and payments per year. And then to get to the question that was just asked, this is where we look at the escalation rates or the increase on costs for electricity, as well as gas and carbon taxes. So if, and this is reflected in that total cost of ownership calculation. So if we're trying to understand what's the total cost of ownership over 25 years, and we anticipate electricity costs will go up by 1% or 1.5% per year, it'll calculate that for us, as well as carbon tax or natural gas. Gotcha. So yeah, that's I think a pretty important one to be able to predict what the cost will be on an ongoing basis to operate that house.
And out of curiosity, just in terms of the tool being an open data tool, in the sense that, like you guys identified, you can change the values in certain fields, and pretty much almost a lot of the fields you can change the data. Would you be able to kind of like, let's say a person, would you be able to like change the fields and make it, customize it for your own needs? Like, is that something that you've seen builders do or users of the CBAT tool do?
Yeah, absolutely. I think that's where you have to start off. I think if you're, you'd be remiss if you didn't do that. So, builders, they can go ahead and modify what their profit margins might be or their overhead costs and contingencies. So when they're doing their calculations for construction costs, they're including all the numbers. It's also important to update, the home buyer finance numbers. Mortgage rates are pretty, lending rates are pretty low right now. And so we'd want to make sure that this number accurately represents what a homeowner might be expecting or seeing in the market. And so, yeah, I would say absolutely every time someone uses the tool, they find these numbers in here. I mean, it's great to double check them to make sure that they're accurate and, the utility costs are correct for your region. But yeah, if you don't update them and if you don't customize them to what you need, the recommendation or like the solution you're going to get out the back end is going to be that much less meaningful to you.
Perfect. Thank you.
Okay. The GHG intensities are here. These come from, as well as the utility rates, these get pulled in from like a preloaded data set here. These are GHG factors. They're the ones that are used in HOT 2000. So they should be consistent with HOT. Utility prices come from there as well. There is from October of 2020. So if they've changed, then definitely encourage you to update those. We can also input incentives here on the right-hand side. So these get calculated with the cost of construction. So they're assumed to be builder incentives. So whether the builder is getting an incentive to hit a specific tier in the code, whether they're getting incentives to put PV on as well, or incentives from the local utilities. We talked a little bit earlier about fixed costs or fixed budget. So if you have a fixed budget, this field opens up for you and you can then tell it, I have $10,000. Tell me how I get the most bang for my buck. So we can play with that afterwards as well. 2 checkboxes here. One of them is if we're building with PV. The other one is if we're building with cooling. There's different codes that require different checkpoints. In BC, there's different requirements if you have cooling or not. And if we're constructing with PV, then we want to make sure the tool's accounting for that in our energy cost calculations, as well as for our net zero or net zero ready targets. Okay, that's it for the inputs tab. Any questions? We've answered a lot of questions so far, so hopefully everyone is.
Yeah, I think everything seems okay. The only one question is Mohammed was asking just the best way to contact with the HOT 2000, the CBAT, and the HTAP development team. It's okay if people reach out to you, Lucas, to let you just get in touch with you. Is that right?
Yep, that's correct. So if you're, it's a great question. So that just goes back to like that working group I spoke of earlier. If you're interested in learning how to take your Hot 2000 file, run it through HTAP, and generate a CBAT file for yourself, then for your project, then reach out to me, please.
Perfect. Thank you.
Okay, so off to the optimization tab. So we were here for a moment before, but we'll spend some time going through it a little more slowly. On the left-hand side are the energy conservation measures. So these are the ECMs. These are the performance specs that we've specified. It's a static list, meaning that like you can't change this number to R55 and expect that CBAT can account for that in the energy calculations. So those have already been done, and so all of the data set is already in the tool. So we don't do any sort of energy calculations in the spreadsheet itself. Everything comes from Hot 2000, and that kind of provides consistency, I guess, for the values that come out of this tool. And so if you want to, if you'd like,
do you have an energy advice?
Oh, did someone have a question there?
No, sorry, I forgot to mute someone. Sorry.
Nope, no problem. And so where were we? If you, you'd have to, it doesn't account for any of the energy calculations, so it provides consistency. So if CBAT recommends a certain package or a recipe, you could go back into Hot 2000 and model that in your final model for compliance, and hopefully, you should get the exact same values there. So I think that's pretty important to align with Hot 2000 as well as ERS, and so that way we're no one's getting their signals crossed here, and we're all kind of speaking from the similar from the same kind of standpoint. Vantage. Oh, anyways, roof insulation options, above grade walls, windows. We jump into air tightness as well as mechanicals. So if what you see here, and this goes back to like the conversation about being able to run HTAP and customizing the tool, if there's mechanical systems or levels of air tightness or R values that aren't in the tool here that you would like to see and consider, you can add those into your custom HTAP run. And once you go through the process of generating that data and importing into CBAT, what you'll see is maybe you can have 1.2 air changes per hour here, or maybe a below grade wall option you're considering is R20. And so you can pull that level of information into the tool. There won't be costs associated with it, just because we can't account for every cost that you're going to possibly pull into this. But there will be a field here that allows you to input what the cost of your measure is, as well as jump into the detailed costs of it and begin to play with some of like the per square foot, like the material as well as the labor, assemble what your all the line items that might go into that R15 or that specific measure are. And so I'll get into that a little in a moment there, where we can talk about detailed costs and how to customize them, so that way you're getting all the right data for each one of your costed items. Did someone have a question? I saw something.
There's a couple of questions there's a couple of questions, but I didn't want to interrupt you because there's probably some hypotheticals that we might want to get into, like there's like how we could use the tool, but I wanted to give you a chance to kind of go through the different tabs.
Sure.
And then I thought maybe it might be a good time to have a little bit of a discussion on the hypotheticals of how it could be used.
Sure. Okay. That sounds like a good plan to me. So for each one of these ECMs that we've specified here, so we've got a cost for them. We see here is like a big bulk cost. So we're saying an above grade wall cost, $8,350. And so you might ask yourself, well, how do you get to $8,350? What goes into that above grade wall? And so we can look at that by typing yes into column G here, going over to the costing module. So each one of these buttons changes what our screen looks like on the right-hand side. If we click the big button up top here, click to view detailed costs, the tool will go and find our R18 wall. and tell us, what it's made up of. So what is in that assembly? So we have drywall, vapor barrier, framing, insulation, OSB, and the works. And you can go ahead and modify each one of these costs. So we see there's a unit cost for material as well as for labor. If we're getting any one of these materials at a different cost than what you see here, you can modify that by just typing a number in here, clicking the update cost button, and it should update itself in column R here. And what you'll see is like every cost, every assembly that also uses that drywall will be costed out at 32 cents. And you can confirm what any of these costs are by going to the builder line items tab. And so this is where every single unit cost is listed, kind of like a master sheet. And we can see here that it's now 32 cents, and that was our 1/2 inch drywall. And so you can change those costs either one of two ways. You can go and play with that table that we were just in, the little module, or you can come to this master list and just kind of dump all your costs into here in one shot and have them accounted for throughout your analysis. A feature that we're currently working on right now is being able to modify what your assembly looks like. So, maybe instead of bad insulation here, like we're going to put, well, no, you wouldn't put rigid, but you can change any one of these options or add new. So maybe one of the new components we're going to add is, we'll have a miscellaneous category, and you can add nails, for instance, if you want to get into that level of detail, and your cost per square foot in terms of wall area of how many nails you're going to need. If you want to change out, your framing, maybe the assembly that you're building looks at 24-inch on centers. Right now, it's just a big clunky list. We're going to have these specific to the category in a short time, but you can go to the different framing options here, and you can go 2x6, 2x8, 16 on centers, 24 on centers, anyway, and you can modify it that way as well.
There's a question from Dave, and Dave, I might ask you just to mute because I'm not sure. I will admit my ignorance on, is ICF construction an option to choose? And I admit I do not know what ICF is.
Yeah, it's a great question. So we have SIP panels for our above grade walls here. So you'll see in column C here that there's a number of material options. So for our above grade, we've got XPS, EPS, mineral wool board. When we get into our more insulated walls, we've got a double stud option and a SIP panel. And then as we get into our below grade walls, we have an ICF option as well. So
and what does ICF stand for?
I'm gonna let someone else.
Concrete forms.
There it is.
Okay, thank you.
Yeah, so it's got all the different materials in here. If there's a material that you use and don't see in here, we know that this particular element is always going to have an R40 effective value. So changing the material really only affects the cost. So, I could put XPS here and change this cost to be a SIP panel. And, it would, the idea is it would do the same function. It would always know that's an R40 wall. The only side of things that you're adjusting is the cost side of that equation. Cost override. So yeah, we looked at how to change costs in a really granular level. If you wanted to just kind of flick through it with the builder or kind of do it a little bit quicker, you can override your costs by just putting a number in column E here. And when it does CBAT does the calculations, it'll cost that R18 wall out at the new cost of $7,500. In column F is where you can include or exclude your design choices. So we had a question earlier about what happens if you wanted to, even if they weren't the most cost-effective windows, what happens if that was the window you wanted to use for your project. You could theoretically select no to every other window except for the one you wanted, and you'd force CBAT to pick that window and then figure out the trade-offs for all the other different components of the home. So if it was a poorly insulated window, and you force CBAT to pick it, then we might expect CBAT to recommend more insulation in the roof or in the above grade walls or a higher efficiency mechanical system. Somewhere in there is the most cost-effective trade-off to offset those lower performing windows.
with the cost override section, would that be able someplace where you could kind of, let's say, under these anomaly sort of situations of COVID where supply chains have been messed up, is that something, would you be able to use that field to a little bit bring in that more temporary kind of decision making that you have to consider?
Yeah, you could certainly put it in the cost override section here. I mean, I think today, whether you know a specific element or ECM, if you know what the cost is going to be, then you can override it here. I think, the other option, like we talked about, is changing the per unit cost. So we know the price of lumber is quite volatile these days. And so, you can, on a daily basis or an hourly basis, you can update what your framing costs or your cost of lumber is here. And then that'll be reflected throughout the tool. So yeah, there's a number of options to kind of adjust these costs to make them more reflective of what you're seeing today. It's just a matter of how much granularity you want to get into.
Perfect. That makes sense. Thank you.
Okay. So we've talked about costing now. We've changed some of our material costs. We know how to flick through our different costing items and how to potentially build an assembly in the coming version of the tool. The next thing to look into is you can look at the incentive module. And so as we go down the list here, if there's any incentives for any particular ECM that we have here, like if a municipality or someone's offering, $2,000 incentive for a heat pump, we could put $2,000 here, and that's a heat pump water heater. Same idea. You could just put it wherever, and the tool will account for that incentive. And this incentive is also going to go to the builder, so it gets included in that construction cost.
And so you would just manually set the incentives based on what your local circumstances are.
Yeah, that's correct. Yeah, it doesn't do any fancy stuff where it pulls in all your incentives.
Yeah.
I wish. I wish.
Yeah, something that would be a little bit hard to maintain, eh? And then one question is, do the archetypes assume thermal bridging has been removed for stud walls, for example?
No, I would say the archetypes. So thermal bridging is probably most accounted for in the performance, or like the effective R value of our components of the wall, or wherever else thermal bridging might be happening. And so we account for it in the assemblies that we create. So right here, we have an R30 effective assembly, or in this case, we have an R18 effective assembly. And what that's saying is, you need R24 BAT in between your 16-inch on centers, and the calculation to ensure that this is R18 effective considers thermal bridging, the thermal bridging of this number of studs at that spacing, and the level of insulation and all the components here. So that's where it gets taken into account. Hopefully that answers the question.
I think so. Alan, if it doesn't, just feel free to unmute. Makes sense to me. I mean, again, this is always where the element of the modeling versus the real world situation happens, right? That's all like same thing. We find that when you monitor the performance of building code built buildings, very rarely after occupation do they actually achieve the standard. So that's probably, there's the occupation, how it's being used. There's how much the thermal envelope integrity has been maintained. That's what, same sort of thing with regards to how making sure the electricians haven't broken the thermal envelope for the building, and that it's actually performing the way it was designed to be performed and all that stuff.
Yeah, absolutely. Yeah, it's important to consider all of those components of it. And yeah, that's where the building science and the good practice comes in. I mean, you can model something, as many times as you want, but if someone sticks a hole in your air barrier, you're not going to hit 1 air change per hour, right?
Yeah. And then another question from Adrian is, how about thermal bridging of penetrations? Any consideration accounted for?
I would say like as much as whatever is accounted for in Hot 2000. So Hot 2000 does all of the energy modeling. So, I mean, the question would go back, the question is, does Hot 2000 account for, protrusions in the, in the envelope? And I think the answer is yes. I'm sure a lot of you on the line probably know better than myself and are more familiar with Hot 2000. But if it's done in Hot 2000, it gets carried across in the simulation results we use in CBAT.
Perfect. And then there's another kind of, so we're getting into some hypothetical questions that I was like, but I wanted to kind of get your insight for when you think it's better to kind of go into the hypotheticals.
Sure. Yeah, maybe let's give me 5 or 10 more minutes.
Absolutely. By all means, keep going.
Okay.
Sorry.
No
Sorry
problem.
for the interruptions, but
No.
it helps a lot for helping people wrap their heads around it.
No, absolutely. I more than encourage it. So this is where we look at our optimal solution. So to get here, I clicked through these buttons in column H. So I clicked optimization module, and that brought us to this screen right here. On the left-hand side, we see what our base case is. So this is, a zone 7A house. For gas, this is a gas base case. And so we're trying to understand, what's the incremental cost of getting to tier 1 or tier 2 or tier 3 or tier 4, or any other performance spec we want to get to. It describes how much energy is used. In this example, we don't have any PV on the roof for our base case. We use this amount of energy from electricity as well as natural gas. Total consumption, we can look at the construction cost of these ECMs. And so I'll spend a moment here explaining what construction cost means. So what we're considering in this number here is the contingency, as well as just the contingency that's built into this one here. So whatever in the inputs tab, scroll back here. So it's a contingency here. So it's the percent additional cost above the incremental cost. That gets included in this calculation here. And what we're looking at is essentially all of these costs in column D that are associated to an ECM. They get added up based on what values appear here. So, on our 50 ceiling, we see is 1,380. The would cost X amount, and you summed all of those values up, you would arrive at this 39,000, or sum those values up and multiplied them by 1 plus the contingency percentage, and you would get here. To the buyer, that includes the overhead, the builder's overhead, as well as the builder profit. As we develop this tool, I think it's going to be, what I would like to do is incorporate a way for any of the users to kind of modify these calculations. So, maybe if you want to see builder overhead in the construction cost, then maybe you can modify that. Or if anyone has any thoughts on how these calculations are done right now, please feel free to share them with me. And yeah, we can work toward making this is kind of this is where like CBAT kind of does its calculations and puts out information that's meaningful. And so this is where feedback and suggestions and input from those who are going to be using the tool becomes really valuable. And so how we present and display this information, yeah, it's kind of going to be the make or break for kind of making that business case, making it like a compelling case for moving forward with some of these designs and more energy efficient measures. The cost, and then the last one here is the total cost of ownership. So we talked a little bit about the life cycle costs and what the cost looks like over 10, 15, 25 years. And so what this is saying is that to own this house, or to own the ECMs, as well as pay for the utilities and carbon tax, the maintenance, as well as the replacement of all of these measures over the course of 25 years, would cost the homeowner $120,000. That's in today's dollars. That doesn't account for time value of money, but I think it's all it's all a wash when you start doing the comparisons at the end of the day.
So Lucas, Out of
Yeah.
curiosity, what is that total cost of ownership? Is that the total cost of ownership for the building, regardless of the ECMs, or is that the savings that would get materialized as a result of the implementation of the ECMs that is part of this example?
So this.
I know I probably confused you on that one.
No. I understand. So if you wanted the true cost of ownership, like as I described before, the cost of ownership is like owning and operating the house. And so, well, purchasing, owning, and operating the house. So if you wanted the true cost of ownership, you would figure out what the cost of building the home was, irrespective of these particular costs here. So, what are your shingles? What does it cost to put the flooring in, your paints, your kitchen, all that stuff that gets included in the home. So if you summed up the total cost of the home, you'd maybe add, well, depending on the market, anywhere from like, another $200 to $1 million to this price tag. But it would only look at the values that you've put. We'd only look at the values that we're specifying to it. So right now we're only asking it to compute the total cost of ownership, because we're only really looking at the cost of these components, because they're the components of the home that affect the energy performance of it. And CBAT is targeted at assisting with those types of decisions, not, should I go with granite or marble for my counters?
Mm-hmm. Yeah, I totally get that.
Yeah.
So, but it does mean that if, let's say, if the cost of installing these ECMs came out to like about 40K for this home, right?
Mm-hmm.
And then the total cost of ownership is about 120. Does that mean that, like, I'm still confused in terms of the total cost of ownership? Is that meaning that if you had not, the total cost of ownership with these ECMs is going to be 120 over this time period, but it doesn't compare you to like an archetype of like a code building that doesn't have any of those features. You would have to run two different runs, one with like general building code, not including some of the additional energy efficiency measures, and then one including the energy efficiency measures, and then compare those two. Is that correct?
Yeah, you got it. And maybe if I just show this on my screen here, it'll help everyone's understanding a bit. So this is what our base case is. And so if we're wanting to do a comparison, now we can see, well, this has a slightly lower cost of ownership than our like reference house. And so what this is saying is that, this cost of it's taking this cost of ECMs for the buyer, and adding onto it over the 25 years, whatever the costs of utilities would be, as well as maintaining and replacing any of these measures that you've put into the home. So that's kind of what the total cost of ownership looks like here. So we're not taking into account, we're only taking into account these measures if you're looking at like a cost point of view, as well as the energy that's being pulled from, the cost of energy as well.
All right, perfect. Thank you.
Does anyone else have questions on that? I mean, if maybe I still haven't explained it super well.
No. There's a couple of questions. Does the code include heating domestic hot water by heat pumps? So the code, the National Building Code, doesn't give you those kind of prescriptive sort of things. That's something that, okay. So it is, well, we would be getting into hypotheticals. I didn't want to kind of get into the hypotheticals because I know the questions will start to really come in when we start going into the hypotheticals. So I didn't want to push it just as yet.
Okay. We're getting there. So now we've seen what a solution looks like. Some of the information that, gets presented to you. And yes, this is what a tier 1 house would look like. We can look at it from cost of ownership, from, this metric of lowest dollars spent per greenhouse gases saved. I think that's an interesting one because it kind of, makes you ask the question, well, am I spending $1 to reduce every kilogram of carbon? In this case, we're spending $1.78 to reduce a kilogram of carbon. Or am I spending, $10 to reduce a kilogram of carbon? I think that's a pretty interesting insight from maybe a policy or, decision-making perspective. So we go back to our energy efficiency levels. So, we can scroll through up to like a tier 3 home. We can see that, now we're at a 20% improvement. We need to reduce our heat loss reduction by 10%. And there's also a metric in the new requires you to have a lower peak cooling load demand than the reference house. So any solution or recipe that CBAT spits out will comply with that. So if we go to a tier 3 house, let's change the metric to capital cost. And so we can see here that it's telling us we don't have to do a whole lot to get to tier 3. If we put in, an R22 wall, we need to put a slightly more efficient HRV. But this is an interesting one because, it tells us to go to electric tank and electric baseboards, which.
Yeah, that's crazy that it would tell you to go to electric baseboard.
Yeah, it is. And I think we know it's quite a bit cheaper, I think, to put in electric tank and electric baseboard. It's not necessarily super.
Oh, is that because we chose capital cost?
Yeah.
I get what you're saying. Okay.
Yeah. So you can see, we're telling you, how do we hit tier 3 for the lowest construction costs? So, baseboards, you don't have to run any ducting. It's just it's pretty super simple to put it in. Although you may need ducting if you're using an HRV. So, maybe this is where you apply some building science or constructability smarts and say, this might not be the solution we're looking at here. And so what you can do, and, if you don't want to put in baseboards and you don't want to put in electric tank, what we can do is go down to our yeses or nos. And so we can say, I don't want to put in an electric tank on my domestic hot water. And, let's move away from baseboards because we just don't want to be putting those in our new homes. No reason not to. It's just, they're super good in terms of maintenance and replacement costs. If we do a total cost of ownership calculation, baseboards win, a lot of the time, depending on obviously the fuel mix and the cost of utilities. But so now we can see that it sent us to a natural gas system and for both hot water as well as our HVAC. And so we've still hit tier 3. I forgot to save the last one, so we'll save it and we'll do a comparison of the two. But it's likely that this option is going to cost more than the other one because now we've eliminated one of the potential optimal solutions. So if I go test 1 here, we can save this solution. It pops up in our results tab here. You can clear any one of these if you so feel like it. If we go back to our optimization tab, just so we can do a quick comparison, we'll give ourselves all the baseboards back. And you'll notice some options here have cooling and some options don't. And so if your builder wants to put in cooling, then you would select no to the baseboard that doesn't have cooling or the natural gas furnace that doesn't have cooling. Or the combo system. So you can kind of manipulate the tool in that sense. So we'll click to optimize again, and then we can just look at the difference between the two solutions and see how we got to step 3 in two different ways. So zoom in a little bit. So let's see, what do we get the difference between the two here? So really the only, we got from an electric tank, we got to go with a slightly less efficient HRV. That kind of was the defining feature here. We use slightly more energy consumption on this side of things with going with baseboards. If you look at total cost of ownership, we're about $10,000 cheaper over the 25 years likely because of this electric equipment. And then the super interesting one is the no carbon savings. We hit tier 3, we went all electric, and we're using quite a bit more carbon. So it kind of really speaks to how important when you're doing these calculations that the grid intensity.
That would be because with Edmonton is our case. Is that correct?
Yeah, exactly. So electricity out that way, they're burning, it's the coal, it's coal-fired electricity. So the emissions factors coming out of electricity versus gas are quite a bit different. And when you put more emphasis on electricity out there, you end up using more carbon.
Gotcha.
Mhm. So yeah, so that's an interesting one to me. I think that one's eye-opening.
But that is really eye-opening. It really helps you play around with it to kind of figure out like, okay, so because that's always one of the things, like, how would you, like, I always kind of had this curious, like, how would you achieve a net zero energy building and still have a lot of GHG emissions? I don't understand, but there are examples that this would kind of help you kind of understand the difference that happens when you use energy versus GHGs versus costs as your different metrics to play around with it. It does really, when you get to kind of like look at it from one perspective, you see the pros and cons. Yeah, no, I see a lot of good things you could learn from looking at it from different lenses.
Yeah.
Hey, Gabby,
definitely.
just one thing, you had a
Yep.
question about ICF, so insulated concrete forms. That's a good case about very different, your energy performance versus your carbon footprint, using a different kind of foundation. So that would be one that's, yeah, I imagine will be very different results for this. Once they start looking embodied carbon.
Absolutely. I think embodied carbon is really important here. I mean, if we're right now, energy is our metric. And like, as you're seeing with this example here, it might not necessarily, the one we just looked at, rather, it might not be like the correct metric, right? Just energy. I think we really need to look at GHGs. And when you think about GHGs, it's not only the operational GHGs, but the embodied carbon in the materials as well. And I think I have a hunch that if we consider embodied carbon, and have carbon as our metric, we might recognize that we don't have to go so far down the rabbit hole of energy efficiency, because if we're looking at carbon, there's other ways to have that reduction beyond just how much insulation you put in your walls, or how high of a COP you can get your heat pump to in the winter. And so yeah, I think it's going to be really, really important to look at it through that lens. And hopefully, yeah, we're working hard to integrate embodied carbon to our analysis tools as well. My colleague, Patrick Langevin, he's actually worked with him and Chris Magwood worked together to develop an embodied carbon calculator that for NRCan. And so hopefully we'll be able to share that with you on the call pretty soon. It's just we're just finalizing some of the putting the finishing touches on it before we release it. But yeah, once you consider embodied carbon, operational carbon, and like the fuel intensities of the grid, or the GHG emissions from the grid, it puts a whole new spin on things. And I think it really changes, how far we need to go in one direction. And there might be more cost-effective solutions if we look at, carbon as our metric. Okay, I'm going to press on here. So I've toggled what you've seen. I've toggled from what would have been a total cost of ownership calculation to like a lowest cost per GHG saved. So this was that metric I spoke of earlier. I'm gonna save the solution here, and we'll compare what we have. And so steps. These are all tier 3 homes. These two are capital cost. This one was lowest cost per GHG saved. And so what we're saying is, how do we find, how do we spend the least amount of dollars to reduce the most amount of carbon? And this is kind of what this metric looks at. And so in the first example here, test 1, we can see this ratio meant that we are spending $2.74 for every kilogram of carbon we are trying to save on an annual basis. And then in this example here, when we pushed it to all electric, we saw there was no carbon savings. We went in the opposite direction. And when we went to our final one, where we optimized for lowest cost per GHG saved, you see we're down to $1.67. So, we saved about almost a whole dollar on the in reducing carbon there. So I think when I'm still not really sure where this metric lands in terms of like what audience and what group, but I think it's super interesting, at least from like a policy and like a government incentive perspective, where if we're trying to incentivize, reducing carbon over the total lifespan of that home, we probably want to be sure that we're not leaving any dollars on the table, and we're not spending, $5 per kilogram reduced, and we're down as low as possible.
And then just for the example where the cheapest or the most biggest bang for your buck on GHGs and dollars spent, that combination system that's here, is that a combination heat pump, like between like hot natural gas and electricity?
Yeah,
Or-
exactly. Yeah, yes, it's a combination. I'm gonna.
Sometimes they're called combi boilers, and they'll do your hot water for your building as well, like for service hot water, as well as it'll be running through like a radiator system. I've seen that as called a combination system, but maybe you mean something else.
Nope, you're correct. And so it's just it's a space heating and a hot water system combined.
So it's a natural gas like furnace that does both heating and hot water heating in a combination unit.
Yeah, exactly. Yeah. So
Okay,
it's
gotcha.
yeah.
I don't know if you call it a furnace. I think they call it a boiler is usually
Okay.
it. Yeah.
So yeah, you'll notice if we go back to comparing these two, when we're talking about lowest cost per GHG saved over the lifespan of the building, you can see how the tool just kind of went to the extreme in terms of boosting up our envelope performance. And I think that what that speaks to is, if you go envelope first, that's always going to be saving you electricity, right? You don't have to put any maintenance into your insulation in the walls. I mean, every day it's saving you energy and, keeping your house either warm or cool. Whereas if we put more emphasis on our mechanical systems, we're having to inject money into them to continue, generating those savings. And so when you look at it over the 25 or 50 years, in terms of reducing carbon and keeping that total cost of ownership down, the tool just pushes you in the direction of envelope first and really tries to max out those components of the home, because we know the cost of electricity and natural gas is going to go up. If you have carbon taxes, we know like those are going to go up as well. And the one thing that hasn't been put into this tool, and I think is another interesting piece to consider as we move forward here, is like the impact of releasing carbon, the impact of like burning and releasing carbon today versus the impact of it in 10 or 15 years per se. And I think most people would agree that it's more important for us to reduce carbon today than in 10 or 15 years. Every CO2 molecule released into the atmosphere today is going to be that much more impactful than later on. And so we should be investing our resources accordingly.
I have to say, I'm so glad that you said that, Lucas, because I've also gotten to rants about the fact that a lot of times with business planning, they'll put a discount rate for investments in energy efficiency because of the way financial systems are, that you normally, when you invest now, you always want to postpone your investment. So they throw a discount rate onto these GHG reduction projects. And you're like, wait a second, no. Every GHG reduced now is more important than a GHG in the future. You can't be throwing these discount rates. I understand it's your financial planning that does that, but then we got to have a GHG kind of, amplifier.
Yeah, absolutely. I think it's a really important conversation, and it really drives the point home of, just going and doing the right, going all the way right now. Like if you think about, you look at this house and it's like an R80 ceiling, like, holy moly, like these are really high performing and expensive components of the home. But any home that we don't build like this today,
We'll only have to get retrofitted.
It's going to have to get retrofitted to this extent. I mean, it's not future proofing the home. There's going to be someone who has to move into the house that is an energy guzzler in 10 or 15 years. And, they're going to have to foot the bill for operating and owning that house. And so, it really is a cost to society, I think. And, if we're building these homes to last 50, 100 years and to provide shelter and, for homeowners and for Canadians, then we really need to look beyond like what this first cost is or what our return on investment is. Like this is a service that we're providing.
Which is, for sure. And then that would also follow up. There isn't a discount rate attached to any of this stuff in the CBAT tool. Is that correct?
Could you repeat that? Sorry, there isn't a reference?
There isn't like a discount rate or anything. They don't do that kind of financial planning or anything in the CBAT tool. It's just about the measures and that total cost. Like, is that correct?
Yeah, that'd be correct. I mean, in terms of financial planning, like you can kind of project what the costs are going to be, like what the rising costs are for different utility rates. For a homeowner, you can, they can calculate their annual mortgage, their monthly, or in this case, bi-monthly mortgage payments. So that type of analysis is considered. The time value of money, and discount rates and like inflation of today's dollars isn't considered in here.
Okay, perfect.
Yeah, we had lengthy conversations with with a lot of folks from industry, and it'd be really good to maybe open it up, open up to this group too. Like, what are your thoughts on like total cost of ownership versus what would be more traditionally like the net present value, where you consider discount rates and inflations and time value of money? From what I heard, maybe I'll leave it there and see if anyone has any thoughts.
Yeah, anyone would like to unmute, provide any input? Go ahead.
Yeah, Kelly here. So net present value would probably be the one that I get asked about and probably most familiar with. And it does do a discounting. It doesn't take into greenhouse gas emissions. It's just inflation versus, where else could you be investing that money and what kind of rate are you expected?
Yeah, my only one beef with the net present value is the fact that it does include a discount rate, which completely undermines GHGs.
They're two separate calculations, though. One of them is strictly on the finance side, and yes, you're right. Maybe there is some other calculator about greenhouse gas emissions, being worth more today than in the future, but that would probably be a separate calculation.
Gotcha.
Yeah, I think you're correct on that one. It would be a different calculation. And yeah, we've included net present value here in the past. I've personally found it pretty difficult, and I've heard from others that it's a difficult concept to communicate. I do completely agree that it's more holistic, and it provides a more true value of the cost, because you are taking into consideration that time value of money. But we've heard from industry that it's been a challenge trying to help others understand that concept. So does anyone else have any thoughts on the topic? Has anyone had any conversations with homeowners or builders about what total cost of ownership or NPV means?
I certainly have heard a lot of kind of the kind of thing that seems to resonate more with like the average person is like how long it'll take me to pay back for the capital investments, right? That's kind of like, the kind of like, even though we know like the payback period is not like, we don't want to, because we've been kind of, a lot of energy efficiency measures have been either kind of given life or killed based on being under some crazy number of like, if it doesn't pay for itself in 5 years, then forget it, despite the fact that that will be around for 15 years, right? So I think that kind of like that payback time period to pay back upfront capital from operational savings is something that people have an easier time wrapping their heads around, but I wouldn't want it to take away from the total cost of ownership, if you know what I mean. Go ahead,
Irshad.
Yeah, so first and foremost, thank you very much for the presentation. I just wanted to maybe provide feedback on this NPV because seeing as to this current tool being only for new housing and seeing the great majority of new housing being driven by developers in Canada, there's a higher likelihood that the folks who would be most interested in the new housing version of this would be those developers. And as such, they are much more driven by their capital outlay and capital costs initially compared to the cost that homeowner would eventually incur throughout the ownership and operational costs that would come in thereafter. So this version of this tool, in my limited observation of what you've presented here, would likely benefit more from an NPV type of analysis, because those folks would be more motivated by their, again, capital and their cost of building that house and selling it off. If you end up coming up with another version of this that is going to be more slated for energy advisors to use with their existing energy audits for existing homeowners, I can see that definitely being ideal for that to look at the total cost of ownership, because when you're having a conversation with an owner of a house who's paying for the operational costs day in, day out, they would likely be more interested in that, as long as they're not flipping the house, which is also another popular thing in Canada.
Thanks for that, Rashad. Yeah, no, you bring up some really good points, and it's important to understand what's important to which stakeholders. And I think you're absolutely right. You know, what builders consider important is maybe slightly different what a homeowner might consider important. And I mean, in my opinion, to me, I think that's a problem. You know, the homeowner, you know, the builder and the homeowner should be quite aligned in terms of what's important to them. And I think that's how we're going to get to where we need to be, you know, as quick as possible. Yeah, so yeah, absolutely. I hear, you know, the importance of NPV, and we can certainly, you know, build that option back into the calculator. It was there before, but no, I'm hearing, you know, it's an important one to consider, especially as we look at different stakeholders and what type of metrics are going to be the most meaningful to them. So we went through a couple of examples here.
So I have a couple of more
Yep,
hypotheticals
sure.
that would be good to kind of dig into a little bit. So one of the ways that municipalities are really looking to have this tool inform them more on is as they're advancing green development standards and asking for different tiers, you know, that are both, you know, either energy or GHG based, wanting to understand what, like, how could the CBAT tool, like, let's say, I'll use an example. Let's say a municipality decides, well, we want you to reach this tier 3 of the TEDI performance standards, and we would like you to submit a CBAT tool analysis identifying the measures you're going to use and the costs associated with doing it, like requiring a CBAT tool analysis as part of a full development application. Is that something that could, what do you think of, like, how can the CBAT tool help municipalities and developers figure out the lowest cost ways of achieving different GHG tiers or metrics in their green standards?
That's a great question. Lots of stakeholders involved, and I think that's lots of stakeholders, lots of numbers involved as well. And so, like, I don't know if the CBAT tool is quite ready yet to be implemented in such a way that it would be mandatory or you know, to submit. But what I do see it really, like, benefiting all the stakeholders in is kind of facilitating that conversation. And so what we're doing, we're actually doing an engagement. We're about to start an engagement with the region of Durham. And what is working with local builders in the region and taking one of their homes that, you know, they're looking to build maybe in the next, you know, year or 2 years, and doing a CBAT analysis on it. And so we're getting the builders to input, you know, so come up with their own HOT 2000 file with their EA, input their costs into the tool like this, and go through the different tiers of the code and start to figure out what it costs each builder to hit these different levels. And I think, you know, once that happens, like, that's where we can actually start the conversation. And then, you know, the builders can speak with reasonable confidence as to what they think it's going to cost them to hit each tier in the code, and the municipality can listen, and you can have this kind of, you know, more insightful, more in-depth conversation, like, you know, down to earth conversation about what the real costs are, rather than it constantly being in, like, this hypothetical world of, you know, it might cost $10,000 or $15,000 more. CBAT's good to actually put numbers to it and to say, hey, look, no, it's going to cost this much more. How do we work together to, you know, to develop this standard, or to hit, you know, different levels of performance cost effectively, now that we can all start to agree, maybe not on one cost, but like, within a range of costs. And I think that's where it's particularly strong. Oh, you're on mute, Gabby.
Sorry, thank you. Jade, you had a mention that if you wanted to add any, you could just unmute and.
Thank you.
Go
Thanks,
ahead.
Gabby. Lucas, it's great to hear from you again. So, I mean, I can elaborate a little bit on the Whitby Green Standard demonstration project, which Lucas was talking about in terms of actually doing the modeling and then building the actual homes and then hopefully monitoring them post-occupancy. We're just starting to work on the MOU between the town and a developer right now. So hopefully we'll be getting started pretty quickly. But I just wanted to go back to the comment around green standards and how this tool could be leveraged with green standards. And I think we're in a bit of a challenge, especially for kind of like subdivision, greenfield-based communities, because a lot of the time, plan of subdivision application, you don't get into the weeds to this level of detail through the application process. Only through site plan do you get into this level of detail. So it's definitely a great educational tool, and developers seem to be really open to the idea of being able to understand the costs with hitting these targets. I definitely haven't seen really any pushback around that, but in terms of how we would leverage it through a green standard, I think it would be more challenging. I would say it's maybe a tool that you would use as encouragement or education to help create, if you're in the process of creating green development standards or you're just getting out on the roads of implementing them, this is a really great tool to work with your developers to demonstrate the why the municipalities are getting here, and then also showing them the how. Because in a lot of cases, and it's particular, and different developers have different attitudes, and in order to get the most success, you need to work with them one-on-one, which I know is very resource intense for the municipality. But if we really are going to get to this above code standard for sustainability, municipalities are going to have to play a bit more of a role around the education of the building science, because there's just, and like everybody, there's just not enough time for developers to go out and learn more. So having this tool in the hands of the municipalities that they can share with the developers, walk them through the process more on an informal basis, I think will help kind of nudge them to make the right decisions. And I was also talking, I've had some fairly in-depth conversations around the desire from the home buyers, because at the end of the day, the developer's building to what the home buyer wants. And what is exciting is that energy efficiency is starting to become a top demand. And one big developer actually informed me it's in their top 5 now of demands is energy efficiency. And we're starting to see a lot of the big developers commit to above code standards. And I think of like the Manamis who, commit to Energy Star. It's really starting to happen, but these are the tools that help inform that corporate-wide decision, making it their business case the norm. That's just, anyway, I just wanted to provide that as
no,
feedback.
perfect. That makes good sense to me. One question I wanted to ask Lucas as well is like another possible way this tool could really help is like, how we've been doing a lot of market feasibility on the retrofits and kind of building these housing archetypes that exist within our different communities. Would it be like one of the ways I think this could serve as like an education and conversation starter with the developers on green standards is, let's say you look at it from the Ontario perspective with, our electricity grid, our kind of local information, and you took your housing archetypes that are the common archetypes that are within your community, and you use those archetypes to do this analysis. And here it said, like if we're going to do it for GHGs per dollar spent, if you applied these measures and kind of like, I'm thinking like a little bit of a one pager for different archetypes for some of the leading practices that will get you to net zero at the lowest cost, capital costs kind of thing. I see that as something that would be really helpful for the CBAT tool.
Yeah, I think you're right. And you kind of got my brain thinking a little bit too, Gabby. Like that's a really good point where they could, use this tool to better understand, what these individual costs are. And if you're able to and so this is part of what my offer earlier was on this working group. If you're part of a municipality, this might be of interest to you as well, where you can run your own, HOT 2000 models, which, the way Gabby just described it, could be your most common archetypes in your community, pass those through HTAP, load them into CBAT, and all of a sudden start understanding what's the most cost-effective solutions to hit any, level of performance in the code. And similarly with, just going back to the new housing front there, what we could use CBAT for is to also, go through the tool. And if we see, let's see, if we go to capital cost and we see, in tier 3 that, it's sending us down to electric. Maybe we want to understand what barriers exist to get to, step 4. Maybe there's a costing barrier if we're trying to implement heat pumps, for instance, or, high efficiency windows. And the tool just doesn't ever pick them because they cost too much. Well, then maybe that might be where a municipality might want to put $1,000 incentive. So that way everyone's picking, the CBAT tool is recommending a triple glazed window, and that becomes the most cost-effective option. So it's good for understanding what the market barriers are in terms of cost, and potentially how much and where and how much to incentivize a particular measure to encourage adoption.
I hear you. That's a really good point, because I was when we were doing the examples, and I mean, this isn't this is the hypothetical, but I didn't notice that it wasn't pulling in heat pumps, probably largely because of the heat pumps being the more expensive capital cost one. And probably I would guess too, it's because this is based on real world data, there would probably be a lot more traditional HVAC systems without heat pumps in the raw data that it's pulling from than there would be heat pumps. Would that have an impact in terms of what it recommends to you, out of curiosity?
How many of them are in there? Yeah, that would certainly have an impact. I think what mostly has an impact though is what the cost is and what the what HOT 2000 models to be the performance of it. Those are definitely the driving factors. Let's see, if we go to tier 4, it might just tell us we need to go heat pumps at tier 4. No, it still says we can do it with electric tank. So it says, yeah, R80 in the ceiling, triple glazed, R30. So it's super interesting, right? And that's because we're looking at it through that capital cost. If we go total cost of ownership, still looks at it that way. If we go lowest dollars per GHG, it sends us back to this combo system. And so this depends on where you're doing the analysis, what type of home you have, what the geometry of it is, the form factor, window to wall ratio, as well as what the costs you input into the tool are. So if we're looking, if it's saying baseboards are the cheapest and you don't want baseboards, then you can make them really expensive or just completely turn them off. Yeah. So you can manipulate the tool in that way, and you can get it to put in, to recommend a heat pump to you. But the fact that it's not recommending a heat pump to us should probably make us, think, are heat pumps really, should we all just be aiming for heat pumps, right? If we're considering, 25, 50, 100 years of this building's lifespan, the rising cost of electricity, the potential to not necessarily reduce GHGs depending on our grid. It's pretty thought provoking. And I think it allows you to, it really lets you answer some questions that kind of spawn as you go through the data.
Yeah. And out of curiosity, are you guys planning on doing some kind of leading practices? If you were in a low carbon electricity grid, I was just thinking of FCM did their energy roadmap. If you're a high growth community with a high carbon grid, here's your chances are, here's the most likely actions. Is part of this as well going to be kind of doing that analysis and answering the so what, that if you want to reach tier 4 and you're in Ontario, here's your best ways to do it from a capital cost point of view, from a total cost of ownership point of view. I was just curious if that's kind of analysis is something that could happen.
Yeah, I mean, I certainly see the value in it, in being able to offer that information. And to some degree, what's done in the building code, right? We say, this is how the tiers are developed, and with considering how much energy they're going to reduce, as well as, our estimation of what cost is. But the discrepancy is always on the cost side of things. So if we say to hit tier 4, this is the lowest capital cost, there's no way that, 90% of the people are going to agree with the cost that we put out there. And
Right.
so I think to fundamentally answer that question and provide that analysis is why we built this tool. So that way you can put your own costs in there. And I think there's a lot of frustration around being told what the lowest cost way to do things are. And, for builders who know the industry inside and out, who understand more about their business than we could ever. They want to figure out how to get there, what cost effective means to them. And you're never going to figure that out unless you have your own costs into the tool.
Yeah, for sure. I hear you on that one. Well, holy smokes, we did take the full.
Yeah, I know. I'm sorry, everyone. We had some really great questions and
No,
conversation.
don't
here.
apologize, Lucas. I wasn't, this has really been enlightening. Yeah, no, I know I've gotten a lot of comments back from folks who had to run off or anything like that, but really they're looking forward to, I'm gonna send out all the links to you so you can access this on your own, play around with it. Keep in mind in terms of keep thinking about how we might be able to use this in a longer, like in Ontario, to help inform green development standards, how we actually inform the kind of move, hopefully the OBC aligning with the National Building Code, all of those types of things. Like when you're playing around with it, think about it from that perspective, because I think that there's some really good work that we could possibly do to kind of answer these hypothetical scenarios or these archetypes, or even education pieces to engage with the development community on maybe the different costs that they might have and the cost perceptions we have as well. But at least I see that as a really huge opportunity to start speaking in less dogmatic ways and in more real world situation ways.
Absolutely. Okay. And so, yeah, with that, thanks to everyone here for joining us. Hopefully you learned a few things. Hopefully you have more questions and answers coming out of this. And if you do, feel free to message myself or Gabby. And like I mentioned earlier about the working group, yeah, if you're keen on learning how to do a CBAT run for your own project, then reach out to myself and I'll connect you with our working group.
Perfect. Thank you so much for taking the time to take us, handhold us through the CBAT adventure. Really appreciate that. And thank you all for joining. I will send you out all the resources that Lucas was mentioning in his PowerPoints, as well as the links, the Google groups and the YouTube videos for helping out. And then if you have any comments and on where you think we should go next with this, or collective analysis using the CBAT tool to help inform green development policies or incentives, please do give me a shout, and we will continue on this really, really important conversation. And thanks again for taking 2 hours of your very, very busy schedule to go on the CBAT tour. Again, Lucas, thank you so much for taking us on this tour. Really appreciate it.
Thanks so much. Bye, everyone. Take care.
Have a good one.